Hey guys, Ryan from Spyker Workshop here, and today I'm going to be showing you how to build your snowcat. This video is for people who order either the STL files of this, or if they order the kit from me without assembly. You'll have to do all the stuff shown in this video here. So I think we'll just jump right in. If you built my snowblower in the past, it'll be very similar. Like before you start going, you gotta drill out your parts, and then there's just a couple pieces of support material to clean up. It's not even as much as the snowblower actually, but your kit will come with this. I don't have the instruction manuals made at the time of this video, but I will have the drill guides and hardware page. So I'm not going to show all the holes being drilled. Actually, I don't think I'll even show any, just because it's pretty much straightforward. If you have any difficulties drilling any of these, you can check out my snowblower video. I go into more in-depth in there. But for the most part, none of the holes on any of these parts are difficult, I guess. But a new change on my drill guide I made here is some of the holes need to be countersinked, but you don't need to use like a lot of force when you do it. Like the holes come 3D printed, countersunken. Like this hole right here, for example. My camera will focus. Like this one, it prints countersunk, and as you can see on the diagram, this hole right here is actually this one. The triangle means to countersink it. But what you want to do is basically just lightly, you can even do it by hand, just spin a counter bit or a countersink bit in there to clean out the hole and kind of smooth it out. If you don't do that, some of the flatheads might stick up just a little bit. But all the triangles mean you gotta do countersinking on them. But then everything else is pretty much straightforward. Here's the drill bit sizes that you'll need. So I'll go ahead and start drilling out the parts, and then I'll see you for step one of assembly. So here's the hardware that we'll need for the first step as we begin assembly on the snowcat. You can see what we need here. Each step will kind of be laid out like this. You guys can pause it to take a look at what hardware you need, and all these counts you can see, but this one you need 18 of these. So to get started, you also need these printed parts that you're seeing here. So the first thing we're going to do is take the M5 lock nut on the back of this part here, and the lock ring will stick out towards the shiny part like that, and we're going to push that in there. You might need to use either a vise or a wrench or something. And then you want to do that to this one also. Next, we need to attach these parts to each of these pieces here, and we do that using the 4.5 or number 4 by 1/2 inch screw. Oops. Those two go through this part like this here. And then we'll screw those down. Then we'll take two of the number 2 by 3/8 flathead screws. They'll go on the inside like this, and then we'll screw those down. As you're screwing these number 2 size screws down, make sure not to use too much force. Like I would for sure not use a drill for this. These screws can strip out pretty easily. So just when you're using these, just be cautious. You know, you don't need to go crazy. Just tighten them up to the plastic, and that should be good enough. So next thing we want to do is the long number 6 by 1 inch screw comes in through the back. I'm going to screw that down. There we go. And the reason there's so many screws in these parts is because these are what actually bear the whole load of the Snowcat, which I think the Snowcat's capable of handling like over 50 pounds of weight on it. So all these screws help, you know, support all that weight. So then we'll want to do the exact same thing with this one, but on the flip side of that. So once you have both of these installed, the next thing we want to do is get these ready. We'll take the bearings here, the 10 by 15 by 4 ones, and 2 of them go on the front like this. You might need to use like a vise, or you might need to clean up the plastic hole a little bit. Each print kind of varies a little bit. And then also you'll want them to kind of sink in the back. This one's a little tight, so I'll use kind of a mixture of X-Acto knife and maybe a file to kind of round it out a little better. I'll tweak the settings on this. You might not even need to do this by the time you have a kit in the mail. But I'll go ahead and clean that up until it just needs to sit in there a little bit. So if you're having a hard time getting the bearing in there, one thing I just figured out works really well is to take a vise grip and kind of evenly line them up like this in there, and basically just kind of brute force it in there. Doesn't go in there very far, but just enough, like that. So then we'll take, and there is a right and a left side to this. Yeah, I believe it's like that. Or actually, yeah, this one here. Or nope, this one. Alright, and then this hole you might also need to clean up a little bit, but I actually did already. And then this will push in there like that. And then on the inside, it's okay if it's sticking out a little bit, but you don't want it sticking out too much. And then you'll do that to both, and then we'll use 7 number 2 by 3/8 flathead screws to tighten them both down. So once you have those screwed in like this, the last thing for step number 1 here is to take the rest of the hardware, use the lock ring on the screw there, goes through the back hole, and then on the inside we'll put not the lock nut, but just the plain nut. Probably use some thread locker on that, and then do the same thing on the other one. So this is how it should look once it's all done. This is actually used for the top modules that go on the Snowcat. This is kind of like the latch that holds the modules on. So now you're ready to move on to the next step. So here's the hardware for our next step. So this step is very similar to the previous step. We're going to be attaching 2 more of these pieces, but this time to the back plates. These are like the rear of the Snowcat, and it uses the exact same hardware as the previous step. You're going to be putting the M4 screws through the corners of these right here and right here, and then the same screws that these used on this will be going on these, like the long screw through the bottom, or the number 6 by 1 inch through the bottom, and the number 2 by 3/8 flatheads coming in from the inside, just like the last step, and then the number 4 by 1/2 inch going through these 2 holes here. And also don't forget to put the M5 lock nuts in these parts before you start assembling them. So once you have that all done, this is what it should look like here. And same on both sides. Next thing we want to do is just take two number 2 by 3/8 flatheads, and we're going to be screwing these parts on here. These also have a right and a left. You want the part that's kind of open on the bottom here to be facing this way on these parts. Like that one goes on this, and this one goes like so here. And then from the back side, we're going to put just one of these screws in here to hold it in place. Should look like this once you get that. It's just kind of temporary to hold this piece for the next couple steps. Next step here, this is the hardware we're using. And in this step, we are going to be installing the idler arms for the rear wheels of the Snowcat. To get started here, we're going to be, there's these M5 lock nuts here, total 4 of them. We're going to be putting 2 of them sunken in these pieces here. The lock rings will face towards the camera there, and then we're also going to be sinking one of these in here on the inside of both of these parts. So this is what it should look like once you get the nut sunken in there. It goes fairly deep in there. I used a punch and a hammer on mine to get it all the way down there. And then this is what it looks like on the inside of here. Sits flush, or almost flush, I mean, it sticks out a little bit like that. So the next thing we want to do is take these arms and the number 6 washer and number 6 by 1 inch pan screw here. And then these will be going through the hole like that. And that'll be screwing in on the back side here, that hole. And they'll screw that all the way down on both. And this is what it should look like once you get it screwed together. Have one facing to the left and one facing to the right like this. And then basically what this is the idler arm. This you'll actually be able to adjust once we have the rest of the screws in there. You'll be able to adjust like how tight the wheels are on the back for the track tension. So to finish this up, the M5 by 40mm screw goes through like that, through this hole here, and we'll have it catch the nut and screw it in tight. And then the next thing we'll do, I'll just show you, take the M4 fender washer with the M4 by 30mm. That goes through here. And then on the other side there is a nut trap for the M5 lock nut. And this is what it should look like once you get everything connected. Got the M4 nut on the back there. And you can see how it works. Once you have the rest of the thing assembled, it'll make more sense, but the rear wheel is what spins right here. And you can adjust like how tight the tracks are with this part. And then I did the other side already too. It's the exact same, it's just mirrored. Same bolts and stuff though. Our next step here, we'll use this hardware. And we're going to start preparing the pieces to make the whole hull for the Snowcat. These pieces are pretty simple. It's basically the same thing 4 times, but a little bit different. All these have rights and lefts. And what you want to do is Like on this part, this basically goes over like that. You want the shiny part facing out towards you. And then on the opposite side, the other, the left and right side of this. So like that, and then above that you'll take the washer and screw down into it like this. Here's it up close. So here's what they look like when I got them all screwed together. Just want to make sure that you keep the other side that has like a pocket on one of the holes, keep that facing the inside on all these. It's the same on each one. And it's a little loose, but it's supposed to be like that. This is what eventually will be the thing that lifts like the attachments up and down like the snowblower. Here's the hardware for the next step. So now we're going to start to get the entire hull ready to join together in one piece. But before we can do that, we need to attach those pieces from last step to each part of the hull. This is how it will look like for this particular side. And then on the back side, this one is like this. And then the way we connect them is we use, they kind of use a mixture of both pan and flathead number 2 by 3/8 screws. So I just went ahead and screwed them all in. Figured it would be easier to show you which screw goes where after they're all done. The pan head goes on the inside here. Pan head's also out here, and then the flat head there. And then it's the same on the other side, just mirrored, as you can see. And then the back sides have the pan head on the inside, and then 2 flat heads on the outside. The, flat heads. And it's a little confusing just because there's, the front and back, and then each have right and left. So just make sure it looks like this. And also, just another note is just make sure not to over tighten these screws. They do strip out pretty easily just because of how small the threads are, but they don't really need to be that strong. Later on in the assembly we'll be adding more screws to help strengthen it up. So the next step here, we'll be using 28 of the number 2 by 3/8 pan sheet metal screws. And now we get to finally connect the hulls together. If you notice, these pieces, they're almost the same, except one has these posts on it. The one that has these pieces sticking up will go on, oops, I got these mixed up actually. Yeah, the one with the circular part that we did in the very first step, the one with the stumps will be on that one. And then what we do is just take those screws and put them in all these holes all the way down, both sides, and the same thing on the back. And here's what they look like when you got all the screws screwed together. It's starting to take shape and strength finally. And then the next thing we're going to do, here's some additional hardware for this step. And what we're going to do is take the long screw, put it all the way through. It should go through all 3 printed parts, like so. And then on the inside we'll put the lock nut, and we're going to do that to all 4 corners of this. Next step, we need to start screwing together the center bulkhead for the hull using 10 of these screws here, number 2 by 3/8 flat. So what we want to do is we'll use these screws to screw in this piece like so, and then the other one on the back side, and then this little piece goes up underneath like this. So here's this piece all assembled. And also forgot to show from like 2 steps ago, these long bolts add quite a lot of strength, to the whole hull. So next step we're going to do is connect all 3 pieces together to make the full hull. We'll be using 8 of these and 16 of these screws. So 2 things to note here is when you connect them all together, the parts that kind of stick out on this side of this bulkhead go towards the part that has like the main sprocket drive on the front with the big bearings there. It'll go in here like this, and then we'll use the flathead screws on just the top one on each side, and then the 2 bottom holes here will be flat screws, and then everything else is the pan head screws. And here is the whole hull screwed together. You can see where I use the flat heads, pan heads, flat, and then pan and flat on the other side. And now it is pretty much all done. The actual hull, super strong. Next we'll be moving on to the wheels and suspension. This is the hardware needed to start assembling the wheels. It's 20 bearings and 60 of these screws. So the way to get started with the wheels is there are 2 different halves to the wheels. There's these ones and these ones. The difference you can see here, one of them's like flat on the top and the other one it's kind of like a cone shape almost. So what we want to do is press the bearings into all these. We'll do that to both of these and all these, and then once you have that, you'll be taking the wheels, kind of lining up the holes through it, and then all these screws will go in the cone side, screwing the wheel together. We'll do that a total of 10 wheels. And here are the wheels all assembled. Next we'll work on the suspension. This is the hardware needed for the suspension. And we're going to be installing the suspension arms to the hull now. First thing we want to do is push the bearings in these pieces here. Here's what it looks like after you press the bearing in there. I had to use a vice grip on mine to push them in there. And then, forgot, we also need 8 M5 lock nuts for the next part here. We'll take each one of these lock nuts on the back side of these with the lock ring facing towards the camera, and we're going to push these all the way down on all 8 holes total. And once you get all the nuts installed, this is approximately how deep they should be. I used the vice grip also to get the nut started in there, and then I used a hammer and a punch to knock it all the way down. So the next thing we want to do is actually attach them to the hull now. We'll take the M5 by 30 millimeter screw through the end like this, and then we'll be screwing them into here on all 4 sides. And this is with all the suspension arms installed. When you're tightening the screws down for these, you'll want to keep them slightly loose. If it's too tight, these will be really difficult to move. You want to back the screw off just a little bit. Not enough so they have any like wobble to them. Like, see how it's like stiff, but enough so they can easily move. And next up, we will be attaching the wheels now using 10 M5 by 35 millimeter screws. So this step is pretty simple. Just for each hub here, we're going to be using the screw through that, and you can pick which side of the wheel you want facing out. They just give the whole snowcat kind of a different look. But yeah, and then we'll be putting each wheel through there and locking into the nut there. And once you get all the wheels on, it should look something like this here. And to adjust the wheels properly, like you see, this one doesn't really spin. You just gotta back the screw off until it spins very freely. Like that. And then you'll also want to adjust those swing arms so they'll pivot under its own weight. So you just kind of loosen it just a little bit. There, so it's moving under its own weight. And that should be pretty good calibration there. Next step, we'll use these screws here. We will be attaching the control arm to the front. Pretty straightforward. One of these goes on the front and on the back, same thing. And small screws go through here, the second hole down. And then if you look at this piece, there is like a right and left way to do it. You want those holes on the top to be facing upright, like when it's at that angle. Like, see how that looks like it's downwards almost? Should be up like that. And then we'll screw those in on all 4 screws. And that's what it should look like when it's done. So for the next step here is where you need to make like a big decision about what you want to do with the whole snowcat. Basically you need to decide if you want this to be the front of your snowcat or if you want this to be the front. The whole thing is designed to be super modular, so you can choose. Really the main difference is where the drive sprocket wheel will be. If you notice, this end you can put a lot more weight on it, so this end would be ideal for using the snowblower, but you don't have to use this end for the snowblower because I sell like battery box weight packs that you can use on the other end to kind of balance the weight out. So if you notice on this end, the way the suspension is set up, the front end is more easily tipped front like that. But if you had a weight box back here, it would be about the same as just using this. It'll make more sense as we go farther in the video, but you can always change it later too. But what we'll be doing next here is deciding where to put the lifting servo to operate this. And there you have more choices too. You could use a lifting servo on the front and the rear, so then you could easily switch between front or rear at any time. But for this video, I'm going to be showing you how to use just one servo, and then the other will be like mounting this bracket permanently so it doesn't move. Because you still need this bracket to use some of the attachments and stuff that are sold for this. So, also for this video, I'm going to be using this Sprocket drive as the front of the Snowcat. So we'll be putting the servo in here. This is some of the hardware. You won't be using all this hardware depending on what you do, but that is the hardware there. And then besides the hardware, we have also these printed parts. This has even more options yet. These are what the servo will actually connect to, kind of like this. And you can, yeah, like that. You can choose between using just one mount or two. Nothing uses this yet, but for the future I made these mounts so you can actually like double stack two servos on top of each other. My plan was eventually I'm going to make some kind of plow that will need two servos to be operated through the Snowcat. So this allows for like future expansion basically. But for now we'll just be using the single ones. So what we need to do is attach these to the servo using the number 4 by 1/2 inch screws. So here I have it screwed together, and there is a right and left on these. The right and left have the holes slightly different, but this is how it should look when it's connected here. And then this will eventually end up in here, but before we screw all that together we need to put the servo horn on. These servos that come with the electronics kit will have several servo horns to pick from. I think we'll actually use the disc on this one since we won't have to cut it, and we're after torque versus, you know, leverage on this. Or I mean, you know, the higher up you put the servo arm, the more throw it'll have, but the less torque. So I would pick whatever servo horn you have that's kind of small like that. And then we need to get the ball joints ready. You'll still need all 4 ball joints for what we're going to be doing. So put all the balls in there like that. Then we will need to use, I added some screws here I forgot about, the M3 by 16 cap. These ones will be used to actually hold the control rod end to the horn here, but we'll need to drill a hole through the horn. And then what we're going to do is actually come through the back side of the horn, put the control rod on the front with a lock nut. Then we will take the M3 by 60 millimeters, which is also 2.5 inches, and we will combine all that together with another control rod end. And once we have that ready, what you want to do is feed it through the hole coming out here, and then underneath here we'll use the M3 by 25 millimeter, and that will go through the ball with a lock nut on the bottom. So once you have that connected, it should look something like this. And then you'll want to go ahead and temporarily connect your servo to your radio So you can, because we'll need to center the servo to set up the linkage properly. So you'll want to bring your servo all the way back, as if it was lifting this all the way back up. And then we'll want to position it approximately where those holes are. And then try and find like the spot where the horn would work. If it's too far this way or too far that way, you'll have to either screw this in or unscrew it. I think I have to screw it in a little bit on mine, because that'll actually make it come closer to the servo. And then just find the ballpark and temporarily fit it on the servo. And then while you're holding it, you can move the channel and just see how well it works. Oh yeah, also can see we're hitting this right here. Forgot about that. You need to actually bend the pole just a little bit to clear that. Just a slight bend in it. And that is pretty much as much throw as we'll probably need. Once we actually get a snowblower hooked up to this, you might need to come back and adjust it some more. Actually, it might be a little too high, so I'll just move one notch back. It's almost good, I think. Slightly more bend. That should be pretty good. So then what we want to do to finish that off is, depending on what servo you have, your screw might be different, but screw this in before you screw the servo down, and then from underneath the snowcat, these 4 holes we'll be using the number 4 by 1/2 inch screws. So once you have everything screwed down, it should look like that underneath, and like this in here. And then you can see as I move the servo, everything looks pretty good. One thing you want to try to do is make sure you use like a really hole that's close to the center of the servo, because that'll give you the most torque. You don't need very much travel, like when you're lifting the snowblower up and down. This should be good enough right here. And then, depending on what you want to do, because you can, the kit comes with enough hardware to do the exact same thing. Like everything we just did here, you can do back here if you want to run 2 servos. But the other option you have is to just permanently fix this up, because then you're able to like hang the battery boxes on the back, and you won't need the servo struggling to hold it the whole time. It'll just be mounted to the frame. So the way we do that is very similar. We'll take one of these set screws here and run this into both of the control rods. You'll want them approximately that far apart, and then we'll use a M3 by 25 screw and the nut to attach it to the arm. And then on the inside we're going to use number 4 by 1/2 inch screw, and that will go through here down into this post on the inside. And it looks like I need to actually loosen this a little bit. If you just unscrew the control rod a little bit, because you don't want it completely tight, but just a little bit out. And then we'll put the 1/2-inch screw in the top like that. And once you get that tightened, this is how it should look here. And that just makes this arm, you know, like connected to the frame. But then easily later on, if you did want to add a servo, it would be really easy to do. You just swap out the rod for the longer one and use the other servo mounts. And also, if you don't want to run a servo at all, like if you just want to drive this thing around, there's enough hardware also, just, you know, another set screw where you can do this up here. So you don't need any servos if you don't want to. One other thing I wanted to quick explain, it's probably a little confusing earlier, but these other servo brackets, you can use these instead of these here. And what that allows you to do is for future expansion or your own custom attachments, you can double stack servos like back to back like this. And then you can have this one have its own control rod arm coming out here. My plan was to someday make a plow that is controlled by some kind of, you know, something out here will move the plow maybe in and out, and you can run that into a second servo using these pieces here. Also, one last thing with the mounts, there's these like squares that the kits come with. And what these are caps that you push in over any unused hole in the front mounts here. Oops. You can see they have like a lip on it. That lip will be on the inside like this, like shiny part facing in. If you run the snowblower on the front, you'll probably want to take one of these out, and then you can use that hole to run the wires out to the snowblower. Next, we're going to start assembling the transmissions for the Snowcat. This is the hardware he'll be using. It's 8 bearings, 12 of these, and 4 of these. And these printed parts here. So first thing you want to do is the number 4 or M4 lock nuts will be pushed into all these grooves, and I recommend using just a little bit of Loctite just in the actual hole for it, because once we get these installed in the Snowcat, the way to screw them in is flip the machine upside down, and if one of these nuts falls out when there's the pulleys in here, it's a pain to get them. I mean, you pretty much have to take it back apart, so I recommend putting some Loctite in there just to hold the nut from falling out. So there you can see I have the nut installed. Next thing we want to do is take all 8 bearings, and these will be being pushed into all these holes here. So there are the bearings in there. I also used my vice grip on these just to make sure they're pushed in as far as they can be. And then during the very first step, the cleanup and drilling of these parts, there's one piece of support material in both of these that you need to remove. So if there's like a big lump on yours, you just got to take it out and use like a knife to kind of clean it up like this. So next what we're going to do is line up the correct parts here. So there's a right and a left side like this. And on the right side here is the short motor mount, and then on the left side will be the long motor mount, and it goes on there like this. And then we'll use 2 of the number 4 1/2-inch screws on here, and same thing on this side. That's how it should look once you get those screwed in. And then next thing we're going to do is also right and left of these parts. But we're going to take 4 of those same screws and screw that in like that, and then same thing on this one. So this is what they should look like once you have them all screwed together. So next we need to get the belts and pulleys mounted. Here are the belt numbers. You need four of these, and then 1 of each of those. And also number 5 by 30 millimeter screws. So I'll start with the long motor mount first. If you notice, there's 2 different types of pulleys. One has really small teeth on the bottom, and the other ones are slightly larger. It's for these ones here. So we'll take one of these and one of these belts, and then we'll take another one of these belts, is basically on each row of teeth. And then on this motor mount, we want the small pulley facing towards the camera like that, facing towards this angled part. That will go in there like that. And then we'll grab this pulley and take the small pulley underneath this one like this. And then we'll take the long, thin tooth pulley here underneath that, like so. And then we'll push the whole part down in here. Then we'll take 2 of the screws going in from this side. Try to line it up here. So you can look through the hole to there we go. So that's how it should look on this one. And then very similar on this one here, except it's the opposite now. So we'll take these 2 pulleys around here, or 2 teeth, I mean, or belts, sorry. Then this one in here. And the small one around like that. Actually had a belt from an early prototype, slightly shorter, but this is the right belt here. Oops. Sometimes it helps to actually put the screw in the first one. Wanted to make a quick note. The screws that you put into the transmission that I just showed you like a second ago, they're not actually the 30 millimeter long ones. They're actually, I had to make a change. They're the 35 millimeter ones with a M5 lock nut on the end. So don't use the 30 millimeter ones, it's 35. Next thing we want to do is get the motors actually mounted to the transmissions. This is the hardware that you'll need here. The kit comes with these smaller pinions here. These are 10 tooth pinions, but I'll also be selling 14 tooth pinions, so you can use either one you want. The small ones will give you much more torque and low temperature motors and longer battery lifetime, while the larger diameter will give you more speed and less torque, probably more motor heat and more battery usage. So I would recommend the small ones for if you're going to be using the snowblower a lot, and then the medium ones might be able to handle the snowblower too if you take it easy on the throttle, but I would get these if you want to just get the snowcat to like drive around kind of like as a basher, you know. So what we want to do is, or you also need some thread locker too, but we'll start with this one here. We'll put some thread lock in here or on the screws, whichever you prefer, but then we'll be using 2 washers with these 2 screws going through like that. And we'll do it on the same on both of these. So once you have the motor started, you don't want to tighten it down yet. Whatever pinion you're going to use, I already preloaded it with some thread locker in there. Find the flat spot on the motor here, and then we're going to put the pinion through the belt like this. Zoom out. And then, you know, line up the set screw with the flat spot. And then before we tighten the pinion down, we'll want to tighten the motor down. Use kind of not too much pressure, but enough pressure to keep the belt, you know, tight like that. And also don't use too much force to screw the motor down. Just enough. So if you go too much, it'll actually damage the mount. Okay, so before we tighten the pinion down, we want to make sure that it's in the right spot, because, you know, there's a little bit of room to adjust it this way. So the way we do that is we'll go ahead and tighten the pinion down just a little bit, so it gets inside of that flat spot on the motor, and then we'll just spin it a few times and see which way the belt tends to move. This one seems pretty good, but if the belt was like hugging this side, you know, you'd want to move the pinion out a little bit or in. And then once you find the sweet spot, you know, tighten it down, but don't go too crazy, you know, just not strip the set screw out. And then do the exact same thing to that one. So once you have everything tightened down, this is what it should look like. And you'll want to be able to easily spin the motor shaft, even when you move the far back gear here. If it doesn't spin that easily, you probably have the belt tension too tight, so you'll just want to, you know, move the motor that way a little bit. Same thing with this one. Next, we'll want to get the sprockets ready to install using this hardware here. And these are like a special hardware piece. They're threaded ends, stainless steel, like hex shaft or standoffs. Those all come with the kit though if you order it from me. And then also these are some printed parts here. So the kit will come with these sprockets here that have the shorter teeth on them, but you can also purchase separately these wide teeth. These are specifically used for the Kyosho Blizzard metal tracks, These still work with the metal tracks, but I made these just because I think they look cooler on the metal tracks, so you don't really need to buy those. These will work with the plastic and metal Blizzard tracks, and also my own 3D printed tracks. So what we gotta do here is you'll probably need to use a hammer to pound this shaft all the way down here, and then you'll also want to fit this down here. So here's the shaft all installed. What I ended up having to do was use this pulley and line up the hex with it, and use this pulley to actually hammer this piece down onto the shaft. It takes a little bit of force to get everything on there. Then what we'll want to do is put some thread lock on these screws. The number are a 632 by 3/8 cap with a washer, and then we're going to screw that down on both of these. And here's that installed. I had to use a 7/64 Allen wrench for this. I recommend, if you're out of the US, you could probably find one of these on like Amazon or something. That's where I got mine. So here's the hardware for the next step. And this step is by far the most complex of the whole build. Basically what we're going to be doing is fitting this pulley on here, sticking it inside the snowcat, and then while it's inside there we need to try and feed the sprocket through here and line up the hex shaft on the inside, and doing all that while the track is on here too. So for the tracks I'm using the Blizzard, or the Kyosho Blizzard plastic tracks, but you can also use the metal ones, and I'm selling my own 3D printed ones also. So first thing we want to do is we actually need to remove the screw, or the nut from this, and because we need to drop this bar down. I'll show you in a second, but we need to access a hole there. So once you have this down and ready, what we want to do, you'll see I did it one of them already. You're going to actually put some thread lock on top of the pulley right here, and then line up one of these number 6 washers and let it dry. The reason we need to do that is when we set the pulley down inside of here, we need that washer to stay on here because we'll be feeding in a screw from a hole here. So I'll quick do that to this one. I think super glue would work okay for this too, but I'm using thread locker just because it's kind of like gooey. And then I'll let that one dry, but this one's already dry. So then what we got to do, take the short motor mount transmission, put the gear through the belt like this, and then we're going to stick the whole thing, get the camera looking down more, stick the whole thing like that down in there, and you'll also probably want to use like a screwdriver or something to kind of help hold it down there. If you can see that there. And then we're going to take our track, and before we feed the track in, check underneath the back idler adjustment. Make sure you have it all the way forward, and keep that loose until we're all done. But have this all the way forward, because you don't want the track being tight when you're trying to put it on. So we'll put the track over the rear wheel, and then put the sprocket into the teeth like this. And then this is where the tricky part comes. You'll have to kind of push that gear down while you feed this through. And this part kind of would help if you had another pair of hands helping you. But basically we're trying to line up the hexagon shape inside here. If you guys can see that. And it takes some doing because you got to get the rotation right and the actual gear in the right position. There we go. There you can see once I move the we don't have the belt tight, but you can see the pulleys moving down there. So then the way we lock everything in, we'll take the number 6x32, or sorry, 632 by 3/8 screw, and there's a large hole here, you'll see. Actually looks like our washer moved slightly. If your washer moves, you might have to take the whole thing off and start back over, but I think I can. There we go, it's recentered. And then we'll be taking that screw, and this part is also tricky. Well, basically we're feeding that screw into the end of the shaft that's in there. So then what we want to do is, this will take probably a while to tighten it all the way down, but just slowly tighten that screw all the way down. Also, forgot to mention, make sure you put thread locker on that screw, because we don't want that backing out, because as you can see how difficult it is to install. So there you can see I have it tightened all the way down. Just takes quite a few turns to get it all the way down there, and then go until it's pretty tight, because what you're doing is you're actually pulling together the whole assembly of the drive shaft. Oops. Because this is what it looks like in there if you were to look inside. There's the two bearings that are from that part that are on each end supporting this. And then both those screws are actually clamping this all together, so it's like one solid piece. So then we'll do all that to the other side, and it's basically the exact same sequence. Thread locker the washer on this while you put it in here, and then get the tracks on and line up and push the sprocket through. So once you have all your tracks tight, I went ahead and screwed that bar back in, and you should have no play on the sprocket this way. If you do, you want to tighten that screw on the inside a little more to kind of pull it all together. So then the next thing we need to do is actually attach the transmissions to the inside. The way we do that is using the M4x14 and a oversized M4 fender washer. I'll do the long side first. If you look on the bottom, there's you can see both holes through there. That slot is actually, so when we start screwing this together, we'll actually pull this back, and that actually adjusts the belt tension on that. So I'll go ahead and screw these both in, but don't do it tight yet, just get it close. So there, I went ahead and tightened all four down, but not all the way. They still have room to move around. So now what we want to do is get a flathead screwdriver or something similar, and what we need to actually apply a lot of tension backwards on the transmission to actually get the belt really tight. So I typically stick the screwdriver down here like this, and then actually pry it backwards like that. And you want to do that, like keep this under tension while you finish tightening the screws underneath. Like you can see the screws moving there. So I'll go ahead and do that. So I went ahead and tightened both sides down. When you're leveraging the transmission back, don't be afraid to use like a lot of force. I guess don't go too crazy, but they should be under a large amount of tension, because the final drive pulleys here, if there's any slack and you're in rough terrain, you will hear it pop and skip over the teeth. But I've never had that happen to me just because I've torqued it back so much. The easy way to check if it's good, grab onto the track and pull it pretty hard like that. If it is loose, you would probably hear it popping right there, and then just go back and try to pull the whole transmission back a little more. But this is what it should be like on both sides. And then one more thing we want to do with the whole tracks is actually adjust the rear idler tension. There's really no exact science for how tight the belt should be, but I've kind of found that when I pick the belt up, if it goes up above the body, it's a little too loose. So the easy way to do that, I actually designed this to be super easy to adjust. You just push this back, and then go in here and just tighten up that one screw. And that's how easy it is to adjust the tension. I guess now it's a little lower than the hull, but that was really easy to move. I would basically go, until it gets really hard to move the idler. But this should be good. Since there's no actual flex to the Snowcat's transmission like normal tank suspension, you can tighten the tracks up decently tight. This is pretty good for me, if you see. So I'll do that to the other side. So while I was tightening this side down, I kind of noticed I went a little too tight, and with the plastic tracks you can actually see it pulling the track back. So I'll just go ahead and loosen the idler up just a little bit. So there we go, with pretty much the whole chassis is done and ready for the rest of the electronics. Just to show you what everything looks like when it's all done here. And then one more thing about the tracks. You can use, like I said before, either the plastic or the metal ones. I have the metal ones here. I find myself using either these ones or my 3D printed ones. The reason for that is, while these metal ones do add a lot of weight, and it's just cooler and more scale, they're connected by rubber. So if you put a lot of weight on this and try driving around, which you can do like with my dump bucket module or the flatbed, when you try turning, the rubber on these tracks will actually stretch. Like you can see it stretch right there. And then what it does is the track will actually get caught in between the sprocket and the wheel here. And I find they just don't perform that good for like heavy weight on the Snowcat. But just driving around without carrying much of a load on top, these would probably be fine. But I would recommend either the plastic or my printed ones. One more thing about the transmissions I forgot to cover. was, say you get the whole transmission assembled, and then you notice one of your belts is too loose. Well, you don't actually have to take the entire transmission back out. The motor screws have kind of a slotted cap screw on the top. So a trick you can use is needle nose pliers on that, and you can actually loosen that just with the needle nose, and then you'll be able to adjust the motor's tension on the belt, and then, you know, just tighten it back up with this. So if you want cooling on your motors, you have the option to do this. All this stuff here is included with your Snowcat kit, but the fans are sold separately on my site. The fans come pre-wired into a single plug that goes into your receiver. But inside the hull here, these mounts here and here, you can use to mount the fans to help keep the motors cool. I'd recommend doing that if you use like all the high speed gear ratios for going really fast. So to get these to work, the airflow, let's see, yeah, shows it on arrow there. My camera can focus. So you want this end to face the motor. And depending on if you use censored or brushless motors, or you know how long your motor can is, you might want to put the fan on this side or this side of that mount. You can do either one you want. On mine, I'm going to have it close. So I'm going to put it like this here. And then we'll take the long number 2 screws, and those go in through there to hold the fan down. And there I have them assembled. Then next we'll use the 3/8 screws, and those will be what we use to actually screw the fan down into the hull. So there we have the motors installed, or fan, sorry. And ideally you want to also buy some kind of aluminum heatsink to put on here, so then the airflow can dissipate the heat better. But these will certainly help keep your motors cooler than they were before. So here is the electronics kit for the Snowcat. You can buy this from our store, and it includes what's shown here, and also the 2 540 brushed motors that we already put in. However, it does not include this servo. Typically, if you already bought a snowblower from me, you'll already have had one of those servos that come with it, or you can buy them additionally on my website separately. The reason I didn't sell it with this kit is because in case someone wants to buy this Snowcat just to drive around by itself without all the lifting features and stuff. So at first glance it looks like a complete mess, but I'm going to go over what all these plugs do. And when you get yours in the mail, you'll most likely have sticker labels. I just haven't gotten around to doing that yet, but I'm going to label each plug so you'll know exactly, you know, what goes where. So to start with on this, it'll come pretty much pre-wired like this, all like the big wire harness here. The lengths might vary by the time I actually start selling these too. But what it's set up for here is these plugs here are for battery power in, so it's already wired up to support 2 batteries. Because in the rear, I don't think I even covered that yet in the video, but this is where the batteries actually go in the Snowcat. And I didn't put these in yet, but these Velcro straps, I don't even think I'll show it on the video because it's so simple. You just put the Velcro strap underneath there, and then you can tie down the battery on each side. And it does support multiple different batteries, like with the leads coming off the side, out the front, or out the top. They all should fit in here easily. And also it'll come with Dean's connectors. I personally use these, but it's easier for me to solder Dean's, and I know a lot of other people use them, so I just use a adapter for this. But yeah, so once the battery power comes into the harness here, a lot of RCs don't do this, but I run a main master power switch, and there's a special harness made up that you can plug in the power switch to it like this. So what that does is once the whole snowcat's all sealed up, it's like a single power button switch to turn like everything on all at once. So in case, you know, something goes wrong when you're out there, just one switch cuts all power immediately. I know a lot of RCs out there, they, you know, have you go in there and unplug the battery, but there's so many systems in this, it needs something like this. And this, if anyone's wondering, it's actually 35 amp rated switch, and there's two separate switching terminals in here, so it's 35 amps for each terminal, so it's a combined, you know, of like 70 amps. And it is an illuminated switch, but since it's a LED, it doesn't matter that two positives are going through the switch. The LED, I mean, it's a diode. That's a little more complicated than the video, but basically you can wire this switch like this, but it'll come like that. And then the plug is also for the cab, which I haven't got around to yet. The cab has this in the module on top, so say you don't want to run the cab and you want to just run the basher body, well, you can unplug this from the cab, either buy another switch or take the switch out of the cab and just install it like this and have it, you know, just kind of laying in the hall with the different body on top. Okay, so then from there, after you can, you know, switch on and off the power, all the power is distributed between the two drive speed controllers. And I believe these are, I think, 30 or 60 amps. I can't remember offhand. I think it's 60 amps. But these are what control the actual drive motors of the Snowcat. And then there's also a spare plug. This is the like power port that would go to your snowblower speed controller. So that's kind of like a direct plug-in, like ready to go cord for that. And then there's three other cords here. Both of these are the same. You can use one of these for the dump truck bucket module. It uses a little mini speed controller to power the dump truck bucket lifting up and down, so you can get the power from this plug here. And then this plug is for like future expansion stuff. I know the ESS1 sound system uses this for its main power plug, so you could drop that in right away. And then there's one other plug. Make sure not to plug a servo or anything like that into this, because this is like main battery voltage, and this plug is for those little voltage meters. I've included these with the snowblowers, but also I'm going to be including one with this kit. So you can just plug that right in there. So that's it for like the wire harness part. And then what also comes with the kit is a lighting kit. This you actually buy just straight like this. I don't do any modifications to it. It comes with two white LEDs, which go on the front here, two red LEDs, which go on the back, and then it also comes with two blue LEDs, which I haven't really made any use for on this. I'll personally just be laying them inside the hull, just because these things were pretty cheap, so it saves me a lot of work on these electronics kits. And then you also get like a modified adapter plug. And this thing, it's slightly complicated, but I'll try to go over it as clearly as possible. So, or also there's the receiver. This will be sold separately, or if, use your own radio system. But basically you need to supply power back to the receiver. Speed controllers have a BEC inside of them, which basically means it takes your input voltage and then it converts it down into 5 volts, because the receivers and all your servos run at 5 volts. So the power coming through this line is actually feeding this 5 volts. So since there's 2 of these, you don't want them both to be feeding 5 volts into the receiver, because they'll kind of be like fighting over who is giving the receiver power. But we can like take advantage of the fact that there's 2 separate BEC circuits, because they're actually limited by how many amps they supply. I believe it's 3 amps on these specific speed controllers. So we have a total of 6 amps of power at 5 volts that we can use. So what this adapter does is, one will supply power to the receiver, which then supplies power to all the servos. So we can use the other BEC to supply power to our lights or any other functions. This way it should eliminate like when you're trying to lift something up and down with the servo, if you have the lights running through the same power, they'll tend to dim and stuff. But we can use this separate power for just the light, so that shouldn't happen. You'll have bright lights pretty much all the time until your battery dies. But there's a special way that we have to do this, because this white wire we still want to be running back to the receiver, because this white wire is what tells the motor, where to move or how much power to be using when you give it the throttle. But we don't want the red wire going there, because the red one is what's supplying the 5 volts to the receiver. So this adapter basically takes out the red wire from here. So this end you'll plug into your receiver. I think channel 1 and 2 are for the drive motors. And then the other end, one of these will go to the speed controller. And then this other end, you can plug either the light kit in here, or any other things you want to just take power from. If you plugged like a servo into here, it would, since the white cords are all connected to here, the servo would basically use the same input commands as the speed controller. So I would use this just for something that needs just straight 5 volt power. Also wanted to make one more quick note, just in case that was confusing about the lights. But these lights should only be powered on 5 volts. So do not plug these into these plugs here that are coming from the main battery power, because it will burn up all the LEDs right away. So here is what I came out with for the layout in this. You'll probably have to play around with it to get all the cords exactly how you'd like them. I kind of left the power switch coming out through here because I plan to use the cab on here, and there's a mount for the cab and the voltage meter up inside the little engine compartment. But if you were going to be running just the basher covers, you might want to have left the power switch inside somewhere back here or something. It's up to you guys. But one of the important things to note is these wires can be touching the motors because they don't get very hot, especially if you bought my separately sold fan cooling upgrade. But that's not really necessary unless you're running like the really fast pinion and stuff. But when you close up the Snowcat with whatever top you're using, just make sure no wires are inside the transmission area. And then here's kind of the basic layout that I was doing in here. In the receiver, channel 1's left and right track, which is the speed controllers. And in here I got that adapter plug I was talking about that removes the power line going from one of these, because you only want one speed controller to power the receiver. And then I will be adding the snowblower to this, but I didn't do it yet. But for the snowblower, it would use this power, and then on channel 3. Channel 4 is the lifting servo that I got up front here. And then shoot servo, which is for the snowblower. The dump bucket, that'll be its separately small speed controller that lifts the dump bucket up and down. So if you never plan to buy that, you can always, replace channel 6 with it or whatever else you want to do. And then number 7 is left kind of open. You can either use it for like a light switch, or if you want to run another servo for the other mount in the back, you could use channel 7 for that. And then channel 8 is my radios. If you buy them from the store, they'll be set up to mix the dump bucket throttle and the right and left track throttles into like a single channel that goes just positive. So what that does is, for that ESS1 sound system, anything you do on that will basically send out one engine signal, like mixing all 3 of those channels together. So I got that in there. And then here's the radio here. I currently don't have this radio programmed with some of these extra features, but it will come with them. But you can see the throttle is being mixed to 1 or 2 channels on one stick like that. And then there's like the snowblower chute left and right, and this is the front mount up and down. Or here, I'll just power the thing on. So like there's the front servo. And then with the control or throttle stick. And one thing is, when you first wires up, if like you turn left and it actually starts turning right, the easy way to fix that is like just unplug the motor wires and swap the motor wires around. And if that doesn't work, you can go into the menu. Holding this minus arrow brings up the menu, and then menu button, edit, and then we go to limits, and then over here, this is channel 1 and 2 are our tracks, so we could invert those if it wasn't moving correctly, so you'll have to play around with those settings depending on what your snowcat's actually doing. And then, let's see, also for the lifting up and down, mine is actually reversed right now. Because you can lift the thing up and down, but the whole channel is reversed. So I'll go back into that same menu, limits, and that was channel 4. So I went and inverted that channel. So now when I go down, it actually lowers the mount. When I go up, it raises it back up. And then this switch is connected in with the snowblower system, kind of. If you watch my snowblower video, the electronics one, I go into a lot more detail. But basically you can set the height of your snowblower, and then just flick that switch to bring it back up. And then when you flick it back down, it returns back to the height that you got set here. Kind of helps to keep, like when you want to turn around, lift the snowblower up. And then for the actual throttle of the snowblower, I don't have it hooked up obviously, but it's this knob is your throttle for the snowblower. And then this switch here will actually turn your snowblower on and off. You can see the channel number 3 there moving around as I move the stick, or the knob up here. And then this switch will cut the throttle completely. And then also, if you have the snowblower powered on and then you lift the front mount up, you can see it automatically brings the snowblower down to idle right there. See that? So the whole profile is set up to be snowblower ready, basically. And then I don't have the dump truck bucket hooked up yet. I'll go into that in more detail on the dump truck buckets video, but it'll be set up to this three-way switch. Like, this will start raising the dump truck bucket, that won't do anything, and then this will start lowering the dump truck. That's it for pretty much the general controls of the thing. I think one of my fans was hitting a wire there. I'll have to clean that up a little. But yeah, then one last thing I wanted to do was to actually install the lights, because the lower hull has mounts for 4 lights, 2 on each side, and it comes with these lenses here, and then the light kit also comes with it. So depending on which side you wanted your snowblower to be driving, because like I said earlier in the video, you can pick if you want this to be front or if this is front. You'd have to adjust your the limit switches and stuff in here. But whatever is front, you want to use the clear lenses for. And you can either use some ABS glue, because these are ABS, or you can use just super glue to glue those in there. And then on the inside, you want to power the lights on so you can see what light is actually coming out of it. And then probably, or actually never mind, they're color coded. I just realized that now. The white wires are the white lights, the blue ones are the blue, and the red ones. So from the inside here, there's a hole meant for the light, you can see. So I probably put like a little dab of super glue on those to hold them in there. And then there's, I don't know if you can see that in the camera, but there's like a little mounting point for a zip tie that you can use to zip tie them out of the way of the transmission. So I'm going to go ahead and install all 4 of those. So one more quick thing about the lighting. It might be a little confusing to hook up just because there's so many wires that come with this thing. Your lighting kit will come with this adapter and this one, and then in the Snowcat we have that one adapter that has this free plug coming from, you know, like I talked about earlier, from the receiver. So what I found that I was doing here was taking this one that has these 2 adapters on the end, plugging it into the light kit like that, and then the other end, even though it doesn't look like it'll fit, you can cram it in this plug here. Just line up the black with the black and the red with the red. And it's a tight fit, but it does get in there. Just like that. And when you get your kit, the plugs might vary, so just make sure you have, you know, the lights going to 5 volts is the most important thing. But then we can see when I power it up, they work here. So I'll go ahead and install them in the thing. So here is the final Snowcat chassis all done with all the electronics and lights installed. You can see I glued the lenses in there and zip tied the lights all around here. And then there was a lot of wires for the lights, so I just kind of bundled them all up and zip tied them in there. And yeah, if you guys are going to be putting the cab on the front of yours, you know, you can mount this switch up in the cab. Same with the voltage meter. If you're not going to be using the cab and you're just going to buy the blank modules, I have a different video on how to install all the other accessories and stuff. This video ran really long, but this is a complicated machine, so I had to go in depth to cover everything. I'll try to split out the sections of the video in the comments below so you can like easily navigate to each step as you work through it and stuff. Send me some comments or emails or anything if you get stuck anywhere, and let me know how building yours goes. So thanks for watching. Or one more quick thing, I forgot to actually turn the lights on just so you guys can see them. Yeah, there's the front headlights, and then the rear ones. So, yep, thanks for watching, guys.